Hey guys, I am going to go over the knowledge check that you did in breakout groups. Some of you finished, some of you did not. This was a formative to get you ready for the test, so I just wanted to make sure everybody had an opportunity to go through it and understand the questions since there may be some similar on the test. Okay, so it says, which of the following ordered pairs represents the y-intercept? This is really what we're noticing is some of you just don't see the y-intercept when you're just presented the ordered pairs. For it to be a y-intercept, it has to have an input of 0. So in this example, 0, -6, 1, 2, 3, 4, 5, 6 would be right here. So that would actually be the y-intercept. It's where the line would cross the y-axis. So maybe it would look something like this, okay? All right, so that's the y-intercept. All the other points, like 4, -3, this would be 1, 2, 3, 4. -3 might be down here. Okay, that's not on the y-axis. All right, looking at the second one, okay, which of the following ordered pairs represents the y-intercept of the linear equation y equals -3x? Now, this type of problem is confusing some of you because we think of slope-intercept form, y equals mx plus b. Well, there's nothing there where the b is. It's not that there's nothing. There is a y-intercept. It's just -3x plus 0. So in this case, your y-intercept is actually 0, which a y-intercept of 0 would be right here at the origin, or 0, 0. So that's how we get the answer. Okay, the third question said, what is the slope of the line that is parallel? Okay, so this unit we learned about parallel, perpendicular lines, and we also learned about line of best fit. So we're adding on to everything about linear equations. This time we're looking for the slope. All right, so the slope, if we're looking at this equation, we really want to first put it into slope-intercept form. It's not in slope-intercept form. That's key. That would be y equals mx plus b. So we want to solve for y. So I'm going to take 3x minus 2y equals 10 and solve for y. And I'm going to do that by moving the term 3x to the other side. I'm going to subtract 3x from both sides. So my -2y is equal to -3x plus 10. Okay, now I divide both sides by -2, golden rule of algebra, whatever you do to one side, you have to do to the other. And we get y is equal to +3/2 x, and 10 divided by -2 is -5. Okay, so there's the equation of the line. Now here's the key word, parallel slope. All right, we can pull out the slope here. We know it's 3/2. Now we know that the parallel slope is the same, so that's also going to be 3/2. So there's your answer. Okay, all right, let's look at the next one. We've got, what is the slope of the line that is perpendicular? Okay, key word here is perpendicular. Again, we need to look at this equation and put it into slope-intercept form in order to get the slope. It's all about the slope here. So we're going to do it by taking the equation 5x plus 10y is equal to 20. And we're going to start by subtracting 5x from both sides. Okay, when we do that, we get 10y is equal to -5x plus 20. All right, and then we're going to divide both sides by 10. Y is equal to, now -5/10 simplifies to be -1/2 x, and 20 divided by 10 is 2. Okay, so it's easy to pull out the slope now. It's 1/2. But we remember our rule of a perpendicular slope. A perpendicular slope is the negative reciprocal, or the opposite reciprocal. This is a positive slope, so the opposite would be negative. And when we take the reciprocal, we flip the numerator and denominator. We get 2/1, so it would be a -2. So there's our answer. Okay, let's look at the next one. We've got, write the equation of the line. So now we're looking for the equation of a line, y equals mx plus b. Okay, that is parallel. There's our keyword parallel, okay, to this line, and it goes through this point. Now we've got a lot of work here. We've got to start by taking the equation there and putting it into slope-intercept form. So 4x minus 2y is equal to 12. All right, again, we subtract our 4x from both sides. -2y equals -4x plus 12. And then we divide both sides by -2. Okay, so y is equal to 2x minus 6. Okay, so now we can finally pull out the slope. That's 2, and our parallel slope is also going to be 2. We want to use this slope with this point now, point slope form. So I'm going to say y minus, remember y minus y of 1 is equal to m times x minus x of 1, and we plug in the values. This would be y minus 1 equals 2 times x minus 1. We would distribute 2x minus 2, and then we would add that 1 to both sides. So our final equation of the line would be y is equal to, let's write it over here, y equals 2x minus 1. And there it is. Okay, negative 2 plus 1 is a negative 1. Okay, so always get your equation into slope-intercept form first, pull out the slope, and then do point-slope form. Okay, so the next question is similar, only now we're looking for the equation of the line that's perpendicular. So again, we're going to solve for y. We're putting it into slope-intercept form, and we do this a lot, guys. This time we're going to add 2x to both sides. 6y is equal to 2x plus 12, and then we're going to divide by 6. Our y is equal to 2 6 simplifies to be 1/3 x, and 12 divided by 6 is 2. So our slope here is 1/3. Now our perpendicular slope would be the negative reciprocal, so a negative 3, or 3 over 1. We now use that new slope with this point, y minus y of 1 equals m times x minus x of 1. We're using point slope form. So y, we're going to say plus 4 because we're subtracting a negative, is equal to negative 3 times x plus 1. We distribute, we get negative 3x minus 3, and then we subtract 4 from both sides. We end up with y is equal to negative 3x minus 7. So that's how we get that answer. Okay, moving on. All right, the next example, we're looking at a scatter plot. We want to know if it shows a positive, negative, or no correlation. Okay, so our scatter plot, if we look at it, envision it going kind of positive up like that. Okay, if we did a line of best fit, it would be a positive slope. So we would say that there's a positive correlation. Okay, now we have a table. All right, so this is where we use Desmos. Okay, and we put our table information into Desmos. So I'm going to just try to pull up Desmos right now so you can actually see me doing it again for a review. So let's see if I have that here. Okay, that should be right here. Here it is. Okay, so here's my Desmos graphing calculator. I'm just going to kind of shift it over a little bit so we can kind of see it. Oops, make it a little smaller. Let's get this into the window here. It's not cooperating. Let me see if I can move my window over instead. Nope. All right, there we go. We're moving. Oh, nope. We're moving it over. Desmos. Okay, here we go. Okay. All right, so I moved the window over so we can kind of see this. All right, I'm going to add a table. All right, so to add the table, I'm going to put in the values for that example. We've got inputs of 4. Okay. Okay, we've got 4, we've got 6. We've got 7, and we've got 9. Okay, there's our x values. Our y values are 4, 5.2, 6, and 7. All right, so here's the key. All right, now we're going to get the line of best fit. All right, and so you can kind of see, if I zoom out, we can kind of see. Let's see our value. There they are. They're in the window. Okay, we got our 4 values. Now we're going to come up with the line of best fit. Remember, it's y1, and then you have to do this little tilde. It's right above the tab key, and then it's ax1 plus b. So this makes the line of best fit. Now what we're looking here is at the a value and the b value. And remember, we rounded both of those to the nearest tenth. Okay, so when we do that, you should have a is equal to 0.6 and b is equal to 1.6. So when I go back, okay, let's go back to my display here. Here we go. And let's try to get the window back again. Come on. All right, it's not cooperating. Come on, we're moving the window back there. Oh, nope, now I'm moving the whole thing. All right, there it is. We can kind of see that. All right, let's move this over. Come on. Doesn't like it in tablet mode. There it goes. Okay. All right, so what we figured out was our A was equal to 0.6 and our B is equal to 1.6. So when we put it into slope-intercept form, it's y is equal to 0.6x plus 1.6. So that's how we get our answer there. Okay, so the next one we do the same thing. Okay, now I'm looking at this example. All right, what you should do here is put in the values in Desmos, okay? And how you do that is you take each of the points and you figure out the ordered pair for it. So this one right here would be 1, 2. This one here would be 3, 3. Then we have 4, 5. And then we have 6, 7. And then we have the last point, which would be 7 and 9. Okay, so put those, add your table, and put them in as your x's and your y's. So it would look like this. Your x1 and your y1. We would have your x would be 1, y would be 2. We have 3, 3, 4, 5, 6, 7, and then we have a 7, 9. Okay, if you do that, and then you do your y1 tilde ax1 plus b, you will find out that your a value is actually going to be equal to 1.2, and your b value is going to be 0.3. So when you put it into slope-intercept form, it'll be right there. Okay, so the next one that you're going to do, your inputs would be the hours of studying, and your test scores would be here. When you put those into Desmos, okay, same way, you're going to add the table, except your inputs are going to be 6, 7, 7, 8, 9 for your x's, your x1, and then your y1 would be 77, 80, 83, 87, 92. So in that case, your x value is going to be equal to, your a value is going to be equal to 5.1, and your b value is going to be 46.2. So if you do it right. So that would be your answer right there. Okay, so I hope that helped. The end for your knowledge check. So again, your test is not going to be due until Thursday. For A days, it would be Thursday, January 8th, and then Friday, January 9th for B days. Okay, thanks so much. Bye.